Welcome back. In this video, we're going to have a look at how we can use the sine rule to analyze non-right angled triangles. In example 1 here, we've got this non-right angled triangle. We have an angle of 60 degrees and a complementary side of 1, and another angle of 32 degrees with a complementary side of unknown length, x. What we're going to do is use the sine rule to deduce the value of x here. Now, first step in doing that is I need to label the useful angles and sides of this triangle. So we've got angle A, angle B, and therefore side A and side B. Now, we're trying to solve for x, which is a side length. So we need to pick an appropriate arrangement for this sine rule here. So we can either do it such that the angles are in the numerator and the side lengths are in the denominator, or the side lengths are in the numerator and the angles in the denominator. What you're going to find is that if you pick a rule where the unknown is in the numerator, it makes it quicker to organize and to solve. So in our case, we're doing a side length. So what we're going to do is we're going to pick this form here. So the side lengths are on the top. So we're going to go B sine B is equal to A sine A. Now, the reason I've chosen B to go first as opposed to A is because we're going to be solving for B here. So I've just started off with the sine rule in a more convenient arrangement. Now, next step is we need to solve for B, so B needs to be the subject. So we're going to multiply both sides by sine B. This will yield a result of B is equal to A sine B all over sine A. Now it's time to substitute in the values. So in place of B, we have x, and x is now equal to 1 times sine B. Our B is 32 degrees. And sine 60. Alright, now it's time to go for the calculator. We're going to put all of this expression here into a calculator to get a definitive result for x. Bringing up my calculator, I'm first going to check that my calculator is set to radians. So I go Shift Menu, and I want to move it to degrees, I should say. So we'll change it to degrees, then exit. Now it's time to do the calculations. I'm going to go for a fraction. Then we're going to go 1 sine 32 degrees. And that's all over sine 60. And thus the answer is going to be 0.61. And this is a quantity, so we're going to call it units. 0.61 units. So example 1, this has demonstrated how we use the sine rule to calculate unknown side lengths. Moving down to example 2, we have another non-right angled triangle. We have an angle here 80 degrees with a complementary side length of 8 and an unknown angle denoted by the variable x with a complementary side length of 7. What we need to do is label all of these quantities. So let's go B and C, and therefore C and lowercase b. Now, next step is we need to decide the form that we want to use the sine rule in. We can either do it where the angles are on top and the side lengths are on the bottom, or vice versa. In our case, we need to think, what are we solving for? In our case, we're solving for an angle. Therefore, it's easier to pick a rule or to pick a form where the angle's already in the numerator. Now, for us, we're going to go sine, should be lowercase, sine C over lowercase c is equal to sine B over lowercase b. Once again, I've used sine C first, even though it comes second in the alphabet to B. I've used it first because that's the unknown we're solving for. So now it makes it easier to rearrange this equation in a form that's meaningful for us. So we're going to go times c on both sides of the equation, which will yield sine c, and then we have c sine b. Now, final step is we need to take the inverse sine of both sides of this equation because we're solving for the angle c, not the sine of c. So that's going to look like uppercase C is equal to the inverse sine of C sine uppercase B all over B. And now it's time to substitute in our values. So we're solving for x, and it's the inverse sine of lowercase c is 7 sine 8 all over sine, mistake, 80, I should say, all over 8, like so. Alright, now it's time to go for the calculator once again. We're going to bring it up, and we already checked it's in degrees, so we won't do that again. But what we will do is we'll go shift sine. This brings up the inverse sine. Then I'll open up some brackets and go for the fraction, and we're going to go 7 sine 80. That's all over 8. Closing it all up and executing, we get an angle of 59.51 degrees. Let's just double check. Yeah, 59.51. So this example here illustrates how we can solve for an unknown angle in a non-right angled triangle. Third and final. We have this triangle here. We've got an angle of 62 degrees and a complementary unknown side length of x. Then we have this angle here, 57 degrees, but there's no complementary side length. And finally, we've got this unknown angle here, but a known side length of 8. What we've got is an example where we don't have complementary side lengths and angles, but luckily for us, we've got two known angles. So what we can do is we can deduce this angle over here. Now, before we do anything, we'll just label all of the quantities in this triangle, and we'll go A, B, and finally C. And then this will be lowercase c, lowercase a, and finally lowercase b. For this example here, we're going to be solving for x. Now, before we can solve for x, we need to solve for c. What we know, because this is a triangle, is we can state that all sides or all angles in the triangle have to equal 180 degrees. So angle A, angle B, and angle C must all sum to equal 180. So because of that, if we've got quantities for A and B, we can go 62 degrees plus 57 degrees plus angle C must sum to equal 180. Now, adding these together, we won't add them, we'll just rearrange it. We'll go angle C is equal to 180 take 62 take 57. And thus, if we bring up the calculator for our first calculation, we go 180 minus 62 minus 57. And thus what we find is our angle C is equal to 61 degrees. So we can put that in there. Now that we know the angle for C, which is 61 degrees, we can start solving this problem. So what we're trying to solve for is this unknown quantity x. In our case, it's labeled as A. So what I'm going to do is I'm going to use the form of the sine rule where the side lengths are on top. So we're going to go A over sine A. And that's equal to, And the complementary angle inside we have is C and lowercase c. So we're going to go C sine C. Now next step is we need to rearrange such that A is the subject, because that's what we're solving for. So we're going to go sine A times sine A. And finally what we get is A is equal to C sine A all over sine C. Substituting in the values, we get not A but X, then C is 8 sine A, which is 62 degrees, all over sine C, which is 61 degrees. Now final step, we plug all of these values in our calculators. So we go for a fraction, 8 sine 62 that's all over sine 61 equals, and we get a side length of 8.08. And of course we call that units, because we don't have units defined for it. In summary, example 3 has highlighted what we can do if we have two known angles, but the complementary side length doesn't line up with these two known angles. In our case, we simply solve for the unknown angle here by using the rule of a triangle having 180 degrees.